Hi, my name is Jackie Decker, and I'm going to walk you through the facilitation of the thinking routine called the 3 V's. Those 3 V's are visualize, verbalize, and verify. Why do we start by visualizing? For a few reasons. First of all, it slows down the learning, which provides quiet think time for our students and allows multiple entry points into the learning for more of our students, which results in more different strategies being used by students. Another important part of visualizing is the building of spatial reasoning. When students are holding and manipulating visual models in their mind, we know that they are building their spatial reasoning, which is really important because spatial reasoning is malleable and it's actually a predictor of success in both math and literacy. So helping students build this helps them build success in a lot of areas. Let's practice visualizing. Pause the video and just hold in your mind this pattern and think about how you see it growing. Once students have had some quiet think time to visualize something, it's really important for them to now verbalize in a small group of 2 or 3. This gives students the opportunity to build their mathematical reasoning by explaining their thinking to each other. They're using math language, and they're trying to understand the connections between the different ways of thinking about the problem, which requires them to actively listen to one another. Practice verbalizing. If you have someone nearby, pause the video and share the different ways you each see the pattern growing. Finally, we're going to verify. We want students to select different tools, maybe manipulatives or a visual model on a small or large whiteboard, so that they can verify their thinking together. This helps students build their understanding because they're making connections between their own model and their own math thinking and those of other students. Take a moment now to choose some tools that would help you figure out what the shape would look like, what the pattern would look like in shape number 4, shape number 10. This is what some others did when asked to verify this problem. You'll notice the group up here, they started with a constant of 1, 2, 3, and a growing portion of their pattern of 2. We still see the constant in red here, but now we see that we've added an additional 2, or now that in the second step of the pattern, we have 2 times 2. In the third one, we have 1, 2, 3 times 2. Whereas another group actually saw a constant of 5 to begin the pattern with that addition. So they're seeing position 0 having 5, position 1 having 5 plus 1 group of 2, position 2 having 5 plus 2 groups of 2, and so on. Beginning your consolidation using student models, using concrete materials and visual models, will make it a lot easier for students to access problems like this. The concrete and the visual are also a great starting point for helping students begin to reason algebraically. When we help students see the connection between this model, and we then ask those students to develop a pattern rule, discovering a different pattern rule that still allows all groups to correctly predict where the pattern is going, will build a deeper understanding of these patterns. And then asking students to build a table of values will help them explain their thinking to each other, which will in turn help them value that tool more. The 3 V's thinking routine is a great way to take any abstract problem like this and open it up more concretely, more visually like this. Another example, take a problem like this, turn it into a 3 V's that looks like this. Thanks so much for listening.